Hello again, my name is Aneta and this is Chemistry at Glance. So, we're working on percentage error now. This comes up in the exams a lot as really small questions, but it's easy to do, so it's worth getting that one extra mark in your exam. Okay, I think it's best to just start with an example. So, in burette, you can have a percentage, you can have an error when reading a burette. Burette is something you use during titration. You have to calculate, you have to read the volume. So the error in a burette is 0.1 centimeters cubed. That's the error. So if you measured your volume to be, let's say, 25.47 centimeters cubed, your percentage error would be that 0.1 divided by 25.47 and then multiplied by 100 to get the percentage. The answer for this is 0.393%. So that's your percentage error when you find in a volume on a burette. I told you that the percentage error on the burette is 0.1 centimeters cubed, but in your exam, you might be told, you'll always be told what the percentage error is. So, for example, I know that there is one exam question which shows you the initial reading on the burette, the final reading is 26.55 is the final reading. The initial reading is 0.25, and then it shows you the titer, which is the difference is 26.3 centimeters cubed. They also tell you the percentage error on the burette is 0.05 centimeters cubed. And now you have to find the maximum percentage error in the titer. This. So in order to find a titer, you need two readings. You need to take your initial reading and your final reading. So you can make a mistake reading your initial value, and you can make a mistake reading your final value. So you need to multiply the error by 2 because you're reading the value twice. So that would be 0.1. And then titer is calculated using these two. So we're not reading this again. So we don't need to multiply by 3. We just read in 2 times and then we find in the difference. And we have to find the percentage error of this difference. So 0.1 over 26.3 multiplied by 100, which will give you 0.38%. So whenever you're told about burettes, you usually have to find the final and your initial value. So you can make a mistake twice. So that's why you have to multiply the error by 2. Okay, so let's try to do an example on a thermometer. So on a thermometer, the error is 0.1 degrees Celsius. And you are told to calculate the change in temperature between 31 degrees and 12 degrees. The change is 19 degrees Celsius. So you have to find the error on this change in temperature. Whenever you're calculating the change in temperature, it's the same as with the burette. You have to find the initial temperature, you have to find the final temperature, and then calculate the difference. We have a difference, so we can make mistake twice. So our percent error, we have to multiply by 2 again. So that's the error that we can make. And now we're trying to find the maximum percentage error on the temperature change. So what we're doing is 0.2 over 19 and we multiply it by 100, which will give you 1.05% error. The higher the percentage, the more it is likely that your number might be wrong and further calculation might be affected by this. There are also a couple of things that you can do in order to avoid error, and that might be one of your questions, to state things that you can do to avoid error. In order to avoid error when reading a burette, is standing at an eye level with the burette. In order to, that's the same thing applies for the thermometer as well. When you're pouring something into a burette, you can use a pipette to accurately measure the volume you need.